Okay. Good evening, everybody. I'm Yorick. I'm one of the developers of the FreeCAD project. This talk here is mostly about one specific project that I've been doing in Brazil with FreeCAD this last year. Lots of people I talked with asked for more. They would like to hear more generically about FreeCAD. So since we have quite a lot of time, we have like up to 7, so we have 40 minutes. So I propose to go quite fast with this, like taking my 20 minutes like everybody else. And then we have more time to talk about FreeCAD more generically. You ask me a question and we talk more about FreeCAD. Is that okay for you? Right. So this Wikilab is the project I will be talking about now. It's basically, these slides I would put that. This is the project we've been doing. It's basically a community-built house. It's not a house. It's actually used as a free software laboratory by the university where it's been built. But the construction system is also made to make anything else, houses of anything. We happen to need a laboratory, so that's what we built. And it's built, this wooden system is the WikiHouse system, which is an open source building system made of wood that is cut by CNC machines, which are robots that can cut piece out of material. And it's built by volunteers. It's extremely easy to build. You see that all these pieces have numbers of them, and then you have a manual. And the only tool that you need, you don't see it, but it's a hammer. It's a rubber hammer. And so it's basically the only tool you need to build it. There is no screw, no glue, no anything else. It's just all together because the system is really well thought that all the joints are made to become rigid. So this is our building after all the work. It's been built during about 3 months. This is the inside. It's not 100% finished. You see that there are still a lot of problems, but it's basically there and it's done. This is how it started being built. You begin to build those structures that you see here on the ground, then you put them up, and then you put the parts that bind them together. I will explain all that a little bit now later on. So we begin to build like that. This is the base wall that we didn't build that ourselves. We just hired a constructor to build these parts that are more traditional construction, and that was also one part of the experiment is to have a mixed system with a part that's built by professional builders and one part that's built with volunteers, and see how that could work together, how the experience of one could help the other, and that was another part of the experience. And that's the actual building with everybody like hammering crazily. And that's really the big part of it. If you look at the result is not so impressive. It's just a little house. But the process of it, everybody there who built this thing went out of there saying, this is the best experience of my life. I actually built a house. And the whole point of the thing is actually to be able to build your own thing. Not so much that the result is so impressive or so special, but it's the fact that you are able to do it with no knowledge at all. Everybody who was there came there without any experience, and after 1 hour you are professional. You understood the whole system, and you can teach the others how it works because you know it by heart. So this is after this is the first person who lived in the house. This is after you finish the structure, you put the panels on top of it, and it's rigid. Normally, it doesn't need any more fixation or anything. We decide to put some screws here to make it stronger, and because we're trying to make it last. Because most WikiHouse-based, I will explain a bit more about the WikiHouse afterwards, but most existing WikiHouse projects have been built inside an exhibition, for example, or there were temporary things that were dismounted after 1 week or 2 weeks. And now there are like, I think, 3 or 4 that are built to last in the whole world. So this is still experimental. We don't know how long it will hold, but we try to do our best to make it last many years. So we did a bit more than just... so that was a big problem. The construction was slow. We had to protect it from the rain, and we didn't think well about that. That was one of the biggest problems we met. Then, since we are in Brazil, we have a very soft climate. Basically, you never have to protect against cold or against heat, because we're in southern part of Brazil where it's never too hot and never too cold. So basically, you can forget about insulation. And I will show afterwards what they used to do in Europe, because the WikiHouse project is from Europe. So they have to be really careful about insulation and not letting any cold or any humidity enter, because humidity is terrible for the wood. It cannot take water, otherwise it begins to rot and to change shape, and that's terrible. But in Brazil we don't have so much of a problem because the air is helping us instead of being an enemy. So what we decide to do, instead of cladding it inside a skin, is to let it breathe. So we use this material, and we left a space between it and the wood, so the air could flow all the time and enter below and escape on the top. So the air would flow all the time and keep the wood dry all the time. And this is working quite well, actually. So it's all open on the sides. The air can flow between all the parts of the structure, because we don't have to care much about being tight, because it's not important there. If you have a bit of air that goes in, nobody cares. It's even better. So we have a completely different situation than in Europe, and we were able to experiment with these quite interesting air circulation systems. And this is the inside. You see the details of how the joints are made, and they are really tight. That's the advantage of having this wood piece cut by a machine, is that the precision is absolute. So you can actually dimension these things to be just tight enough that you need a hammer to put them in. And once they're in, they're like very strong. And so we did a bit of testing to adjust the calibration of the machine, but it was like the first test was okay, because like the precision is built in. And so this is what the machine does. It's basically comes from your model. That's where FreeCAD will enter, and that's what I will explain now. Basically, your FreeCAD file goes to the machine, more or less. I mean, the process is quite straightforward. And this is the pieces being... It's quite a lot of wood. This whole house is like 170 pieces of wood. It's like 2 piles that size, and when it begins to accumulate like that, you really have a problem where to put them before you use them. And a little bit to show you the details. This is another WikiHouse they've been building. They're finishing right now in Almere, near Amsterdam. And there was a bit of competition who would finish his first, and we won. And but ours is much easier, so that's why we won. We don't have half the complexity they had to cope with here. But if you see, it's exactly the same system, and exactly the same shape, and exactly the same problem. So this is the WikiHouse project that we took our shape and our system from. This is a system that was begun in 2011 by two architects in the United Kingdom. They built, I think, above 30 or 40 in the whole world, but those that are still there, that were used to stay, it's about, there must be about 4 or 5 now in the whole world, I think. 2 or 3 in the UK. Now we have one in Brazil, and there is this one in Almere. It's fully open source. You can just take their files and adapt like if it was code. Just it's 3D models and the whole system of how you build it. They have manuals as well. They have a lot of resources outside just the files, which are files as well, but you understood me. And it's now well tested. I mean, you see that the first ones where there were lots of defects in how the joints would work, and the whole thing would go like that. And over the years, you have a lot of people who worked on this, even pretty famous engineers. And the system is now extremely solid. These columns, as we call them, the main structures, is really impressive once you begin to build them. And the more you have like 3, 4, 5 pieces crossing each other. And after the 5 pieces are there, it's extremely solid. Everybody will look at that, and you can really hang a lot of weight on them. And it's a heavy construction, so it has a lot of stability. And it's really something that you feel that it has matured, and it's become something really you can trust. This is the WikiHouse, the whole story of the WikiHouse project. Like, you see the shapes being changing over years, all the research that went into finding the right shapes.
What's the reason why not using screws or some other pieces?
Basically, I would say, I will repeat the question, is why are not they using screws, for example? I would say there is a kind of point they want to prove that it's possible without any other materials, and also the extreme simplicity that you need your hands basically to build it. I find it quite impressive, and you would have screwed, you would begin to need lots more equipment, and there is something incredible in the fact that you just need your hands and a hammer, and I kind of like that, and so we try to. Yeah, you need the machine. Okay. But let's say you have a part that's production of the piece, and then you have a part that's building. And the building part is or you would separate one from the other. And then the building part is like pure without any... but that's true. That's the kind of stuff you find on the WikiHouse website. You grab their files. It's basically all the old ones are based on Sketchup. Those are Sketchup files, but they're not now migrating to some scripting system for Rhino. So you could enter the parameters and it would build the 3D model automatically for you. Of course, we try to port that to FreeCAD. That's what's coming now. That's the kind of material you find there. That's what we used basically without modifying anything, because we wanted to not try anything fancy and take their base system and try to do it well. And next time we'll try to experiment some stuff, but we really tried to do it the best way we could, so we tried not to modify anything from it. And it's basically modular. You make it as long as you want. It's just repetition of modules. In the WikiHouse files, you also find them already separated to be processed to become files, CNC files, G-code files to be used by the CNC machine. So this is all already set up, but we redid that part as well. And then you have like mounting manuals. You see that they say you could use some screws. And so this is FreeCAD. This is the project I'm participating to since the project started in 2002. I've been there since 2008, I think. Yeah, FreeCAD, for who doesn't know it, it's basically a 3D modeler, an open source 3D modeler. It's RGPL license, and it's basically its main focus is that it's a technical modeling application. Basically, we used to say it's used to model things that you will build in the real world afterwards. So it's from electronic components to CDs, basically. Anything you would need to build afterwards, and you would need a precise modeling and controlled modeling that you could do and redo afterwards. It's generic because it's, that's what I was saying, it's multi-purpose. It's used for any kind of stuff. It's not really specially for that kind of, for buildings or for this or for that. A bit like who knew AutoCAD. That was the strength of it. AutoCAD was something everybody used. Engineers, hobbyists, architects, everybody would use the same software. And it's something that has been lost in the commercial world because they want to specialize, because they want to sell specific solutions for each profession. And we like to go back to the old good times with FreeCAD and try to have a kind of application that's just a big generic thing that you just wait for your creativity to work on it. And it's parametric. That's a big feature of FreeCAD, that all objects are defined by the parameters. It means like instead of modeling cubes, you would define an object that, for example, that's a brick wall, and then you would say it has a width, length, and a height. And then your object is defined by these three parameters. And then you can change them afterwards. You change the length, the object changes its length. And everything is driven by these parameters. And that's the website of FreeCAD. That's FreeCAD, basically. It's pretty, for who doesn't know it, it's pretty common application. Like you have a very standard Qt-based interface and a 3D view and modeling tools. It's really, the interface has nothing special. That's the kind of stuff that people do with FreeCAD. Where is Juan? Here. He did it. This one. That's one of the last ones that appeared on the forum. Yeah, people do kind of crazy stuff with it, and more, and houses as well. So one of the first thing we did with this project is convert the SketchUp stuff to FreeCAD. One of the main differences, SketchUp is based on mesh geometry, which are basically points and triangles. Everything is made of points and triangles. And in FreeCAD, we use BREP geometry, which is basically surface. BREP means boundary representation. It means that the objects are defined by their boundary surfaces. And these surfaces are basically NURBS surface. Like every edge of the surface is a curve, of mathematical curve. So you can basically do anything that could be a curve, a mathematical curve. That means you have extreme control over exactly where your surfaces pass through. It's a bit the same analogy as bitmap and vector graphics. Like in vector graphics, you have the mathematical definitions on where the points are. If you zoom closer, you still see a perfect line. And in bitmap graphics, there are pixels. And if you zoom very close, you see the pixels. And it's the same thing. Mesh geometry is like faceted. You already have the location of the points. And with BREP geometry, we can recalculate the triangulation anytime. So you don't have any resolution in it. So we took the files from SketchUp, converted them to, we imported them in FreeCAD, then converted in BREP geometry. And then the thing is, of course, it's like dump geometry, where each point of the object is already fixed somewhere, has a coordinate. And we need we wanted to turn that into parametric object, that you could like stretch the whole thing, or put more modules, or what if I put a window in it, or remove a window, and have all that interesting parametric behavior. And actually, this is something you don't need to do at once. You don't need to have the difference between parametric world and a world that has no parameters at all. You can start with shapes with little parameters and then add progressively more parameter. And next time you take the file and you want to modify one of the objects, you add some parameters to be able to modify them further. And then you can really do that step by step. That's what we did. And then we had all the integration with other stuff that's not the WikiHouse. And then the fun began, is that you begin to be able to produce a lot of interesting stuff from your files. So that's basically what happens. You take these Sketchup models, which are like dump objects, and then you extract the contour of these shapes, and these become parametric in FreeCAD. You can put dimension in these and say, this must have like 20 millimeters, and then you have a parameter, and then afterwards you can change that to 30 if you want, and you don't need to redraw the shape. It would just go for it. All this is really a step-by-step work that you don't need to do at once, and then you can refine over time. This is the finished model in FreeCAD with all the rest. It's not only the WikiHouse. And you see one of the good things is that you can organize that really well the way you want and group the objects by type and do, yeah, of course it's in Portuguese, but just to get you the idea that you can really go into pretty complex models and keep something that's really easy for a human to understand how it's organized. And that's one of the big points, I think. This is when you remove the stuff on top of it. It's really the wooden construction, the inside, and all the piping is there. Everything is in the model, basically. It's pretty complete. And so we had this model that's the whole building, and we had another model that's just one element, and that's the one we use to produce the files for the CNC machine, because it's basically 7 of these modules. So we did just one and used the same output seven times, basically. And so it's pretty well organized already from the WikiHouse project. You have these side panels, you have the inner structure, then you have the reinforcement, and then you have the side plates. Everything is already like defined and separated in the WikiHouse project. You just have to like understand how it works, and it's really amazingly well done. And this is what we end up producing with it. All these things that I will show now that you need to have. And of course, the most beautiful thing of using a free software to do that kind of experimental stuff is that you end up coding, because you end up adapting it for the special case. And so we had quite a lot of new FreeCAD code being done thanks to this project as well. That's the kind of 2D plans that you need to get the authorization to build the thing. You have to, in our case, we were on the university grounds. We had to ask for authorization to all the university instance and stuff. That was the worst part of the whole thing, is to be able to obtain all those authorization. So you need these drawings to be able to show them. Renderings, this is one of the, this project was financed by a crowdfunding campaign. And this is one of the images we had to produce to show that how it would be when it would be finished, to make people want to contribute to the project. There will be afterwards like a call for artists to propose drawings to be painted on top of it. That's not done yet.
But it's done by FreeCAD as well? This render?
No. That you export. That's one of the things I didn't actually explain. This was basically produced by FreeCAD with a little bit of rework in Inkscape afterwards, because some things are still easier to do in Inkscape, to put these texts that are not in FreeCAD. This one basically is the FreeCAD model that you saw, so it's just an earlier version. It was exported in Blender, and a couple of texture, lights put in Blender and rendered in Blender. we try, that's a distance between the two that we're trying to reduce. And the idea was talking the other day with Ton Roosendaal from Blender is to be able to have like a one button you would push in FreeCAD and it would like land in Blender with a preset of lights already on. And you would like have almost a one button render. And he's really interested in developing in this further. So we should be able for the next time to reduce that distance that you need to produce a nice render. And you have other solutions as well that are becoming real-time rendering, etc., becoming interesting to use together with FreeCAD. That you could have all the modeling in FreeCAD and just export some other application to do the final image. These spreadsheets, that's one of the biggest advantage of having a sound model of your building, is that all the quantities are there. How much wood will I need? Exactly how many square meter of wood would I need? How many bricks I would need are there? And then once you have that, putting prices on this is pretty easy. In Brazil, we are lucky enough to have several public sources of prices for the construction that are maintained by federal government. Like they take all the public works they do, and they extract from that the price, the median price of 1 square meter of brick wall, 1 square meter of floor, and so you can. It's public. You can use that for your own project, and it's basically the same price that you will find the day you will build it. So if you have the right quantities, you have a really precise estimation of the price, the final price of the building. That's what we use to estimate how much money we would need for the crowdfunding. And it turned up to be exactly what we spent. Which is around 15,000 euro. 60,000 Brazilian real. It's about 4 now. It's 15,000 euro. Including everything. There is like a fee of the crowdfunding platform that's about 7%, if I remember correctly. Then there is the price of the wood. There is the price of the cutting of the wood, because it's a firm, a company that did the cut, and the price of the guy who did all the brickworks and so.
So the cut was made in Brazil?
Yes. Everything was made locally at like 100 meters from the construction yard.
Did you say 15 or
15.
Like 1.5?
1.5, yeah. And this price is about the same price that you would spend for a brick house of the same size in Brazil. But it could be reduced a lot. A big part of this price went to the company who did the cut. And if you imagine that you would build several of those houses, and that you could have a machine that you could operate with the same volunteers that build, you could reduce that price crazily. So this could be even reduced a lot if you begin to think on a bigger scale or on a more community-based planning. But
Imagine that the price could be reduced if you don't use the CNC.
maybe, but
But
all.
just use screws and the regular.
Yes, you could. Every builder, the builder were looking at that and like saying, you guys are using crazy lot of wood. This could be done with like half the wood. And yes, but then you need more experienced people to do it. And it changed and I think that there is a kind of pedagogic thing that you can build your own house. And you don't need to be especially, you need motivated people to do all the manual work. You can do it really in a simple way. And this project has this crazy capacity to show people that it's really simple. Yeah?
You know, I don't know its English word, static, the forces on the different parts of this house, if that has been ever calculated? Because you're getting forces of wind.
Yeah.
Force.
Mm-hmm.
If you have people living in that, you don't like that this expected, but
Mhm.
such things should be calculated.
Yes, only that this is a really hard system to calculate because you wouldn't have any software that is able to calculate this kind of so many joints and have a precise result. And the effort in all those things is really complex. And I believe this is a system where you cannot have at this moment official calculation of it. You have several important, well-known engineers that work on this system, including Arup, which is maybe the most famous engineer's office in the whole world. They are based in the UK and they're built in the whole world. And they worked on this. And so you have lots of famous people, lots of engineers work on this system. And it all goes pretty much together with experimentation. And each generation of this, how that goes further, you begin to know that they see it and you begin to know it's, I would say it's a common knowledge that goes building together with the building. But that, I believe it's really hard to calculate beforehand.
The wood was with a milling machine done.
Yes.
Was it a choice to do?
Yes.
Not water cutting or laser cutting?
No, it's a CNC machine with a cutting head. That's basically like a drill machine. It's a little head that goes, you put the plate, the wooden plate on the machine, and this machine goes cutting this thing.
There is also our laser cutters that
Yeah,
have less waste.
that is true. But we had a hard time finding, we didn't find a big enough of these machines around the construction yard. And there must be like a couple of them in São Paulo, which is where we were building. And this one was really convenient, and it was close. It was people from inside the open source community. It was much better to go with them because of all the circumstances. And so we like stopped looking after other possible solutions. Probably the laser cut, you would have like 2 firms in São Paulo would do it. They would charge a lot more. And this might have made things go wrong. This is basically the kind of file that you get from your panels. Once you have all your 3D models, these red lines are it's the G code. It's basically the path that the machine must, the head of the machine must walk on the piece to carve it like that. It must go up, go down, and do the shapes. This is basically G code. It's the language that most of the cutting machines in the world, even the 3D printers, use. And they have, each machine vendor has a different dialect. So you have like to do adaptations depending on the machine. But it's basically the same system. In our case, we weren't able last year, in the half of last year, to do it all in FreeCAD. So basically what we did is export these 2D shapes of every piece of the model. And then the shop where we did the cut, they did the G code from these files. Because it was like 8 months ago, and lots have been done since then in FreeCAD that wasn't there at that time, and we had to produce it, and it wasn't there, so we did it that way. But now, so that's the kind of files that were produced from these files. Now we would be able to do it in FreeCAD if we had to do it today. Everything is there to make these G code and export it directly to a file that is ready to send to the machine, basically.
Is that computed or is this manual work?
It's computed. You still have to, for example, you take this face and you have, let me show you the path module. It's in the next slide, but we have now a lot of tools to take one piece, take the driver face of it, and then it would calculate all the paths automatically. So that's all the work that has been basically done last year. There has been a lot of work on that CNC part, and now it's totally possible to take all your panels and from each one generate automatically clear path. And you have a lot of options if the holes have to go before the external profile, if you have to change the order, and that kind of stuff. It's really becoming cool. That's another tool that we have been working on because of this project, is a way to gather a lot of pieces and join them in defined area, which would be your base wooden material, and to try to lose as little material as possible.
Is that done by algorithm or by hand?
This is done automatically. This is this interface is basically what you use. That's the new tool, nesting tool. You define the container, you add the shapes in it, and it's still pretty slow because it's new and not very much optimized. So it runs like half an hour for something like that. But that will get better over time. We need to optimize it. But it basically works. That's the new path workbench. You see that it has quite a lot of tools already. Basically now it works pretty much like you define a project, a cutting project. That's the interface here. You define your base the size of your base material. Where is the start point of your the head of your machine, and then it goes fill this up. This is a typical path job, and so you have a lot of setup to do. But then you just add stuff, add operations one after the other, and the machine will do one after the other.
Does it only work for cutting or also for like 3D?
At the moment, it works only for cutting because most of the people that worked on this are doing for cutting. But it's exactly the same language that goes for a 3D printer. Only the thinking is different because you're not cutting, you are adding materials. So probably we will need to think a bit about it. Maybe some operation need to be thought the other way. But the whole process and the file that goes out of this should be the same. I mean, all the big part, the hard part is done. It would be probably a matter of testing and trying to find what needs to be inverted.
Have optimization for running dry, less movements without cutting?
It's being worked on. There is already a lot done. Like 1 month ago, there were like a big change that in the order of you do first the contour, then you do each hole, and some guy coded something to calculate the distance between the hole and to reduce that crazily because it was like done by its position, and now it's done by the distance between the holes, and so you have a lot of possible optimization to do, and it's a long-term work actually but it's totally being done right now actually. This is the kind of settings that you put on each operation that's in your job. This is the property of each tool. You have some machines that have several tools, so you can change, and so you define them here. So if the program knows the diameter, it will know where the path must go. Like if you have a 1 centimeter tool, you need to pass your line at half a centimeter from the border. So the border of the tool will be exactly on the line that you want.
Tool compensation also for the because one other problem, maybe not with this kind of tools, but for other, is that when you use it, they get they change in shape. So
exactly.
Also the other tool compensation?
Not yet, but it's. On here which line it is. It's getting really interesting to work with. And then at the end, you select one of those post-processor which will convert the generic G-code that we use in FreeCAD to a specific machine. At the moment, there are like 5 or 6 that work well, and the Linux CNC is one of the most well-known controller for this machine. So that's the one that's mostly used. That's the kind of machine that does the work. And basically, this is what we learned from the whole experience of this project. That it's really easy to fabricate. Architects, I'm an architect by trade. I'm not a programmer. I went into this like by my own. But architects are not used to touch the fabrication. They just buy stuff that's existing. And it's totally a new area that we can enter by using this kind of hybrid space between fabrication and architecture, and there is a whole world that's not really much explored, and that it's much easier than what us architects would think, most of us would think. And cost control becomes very precise because you have a lot of data to work with. And yeah, I won't read all that stuff, but there is a lot of experimentation and learning to come from this. And that's it. How we will...
I guess maybe there's some remaining questions, but there were quite a lot of questions already during the talk. So let's get 3 questions. Yeah.
Many professional building software can import via formats like in Netherlands you have Stabu, which is a format of specifications. Do you support exporting to those kind of formats in order that existing building tools can also analyze and work with this?
Many, depends. Yeah, okay. So the question was, can FreeCAD also import and export in several of those formats that are commonly used in the building industry and other industries? It depends. Open formats, I mean formats where you have the documentation available somewhere that you can learn how it works. Yes, FreeCAD has like I don't know, 40 export formats and 40 or 50 import formats. So all we do. Now, most of the commercial solutions work with closed source format, where you don't know what's inside the file. And there is no way to know unless by reverse engineering. This is really hard, and this, honestly, we don't lose our precious time with that, basically, like everybody else in the free software. So there are a lot of usual formats in the industry that are not supported because it would be so much work to try to decrypt them that we prefer to work with open formats. But in the construction, you have a lot of increasingly more and more open file formats like IFC and those kind of formats that are used by all other commercial applications, wanting or not. But they are like forced because the governments are asking for it, so they have to work in. Those are open formats, so we can work with them, and yeah, so you can really plug FreeCAD with a lot of commercial applications.
Yes. I just wanted some clarification. We can make parts in FreeCAD, parametric objects, solid objects. And you showed some pictures of houses that are assembled together with these parametric objects.
Yeah.
And the assembly requires mating of the faces and a connection of. Is this also possible in FreeCAD?
That's one of the main things being worked on, is like parametric assembling, that you would like put one piece face to face with another. And if you move the first one, the other one would go together because they are like glued by face. This is still not. There are many efforts being done. This is still not like built-in and working. This one is not parametric. I mean, these assemblies, you can remove one piece and the others would stay to where they are. But this is something being progressively addressed, and that it's already possible. You have some 2 different plugins that do it. It still needs to be like one final solution that will be built in FreeCAD. It's not there yet, but it's coming.
Okay, one last question.
So is FreeCAD trying to be more like BIM, like Revit?
It's a generic solution, so it's not only BIM, let's say. But yeah, I'm an architect myself, and I want to do BIM with it, and it can do BIM actually. if you think BIM is basically the 3D modeling for architects, for the building industry, for who doesn't know, it's building information modeling. And basically it's how all the construction world calls these parametric models, 3D models, where you can extract all the information from it. And yeah, if you think of it, I used to say BIM is nothing fancy. It's like a 3D model with a lot of information in it. So you can extract from it plans and spreadsheets and all that stuff. All the information you need is inside the model. And that FreeCAD does already. So if you are like bold, you can say, yes, FreeCAD does BIM. Of course, it doesn't show the same, it doesn't look like other BIM applications which are tailored. That was explaining first. They are tailored for specialties and tasks, and we try to be generic. So we don't like to say this is a BIM application. No, it's a generic application. But yeah, it does it. And
the drawings that you showed, were they automatically extracted from that?
yes, with still a little bit of rework, but even with commercial application, you need to do often some rework. So yeah, it's extracted from the 3D, and it's still